According to the World Bank, Indonesia has abundant geothermal resources that can help meet the country's rising electricity demand and increase electrification rates. Indonesia's estimated conventional hydrothermal geothermal resource base is generally considered to be among the largest in the world. The government of Indonesia plans to achieve around 600 MW of installed geothermal power capacity by 2020, a more than a fourfold increase by the end of 2012.
Zeolite is mercuporous aluminosilicate crystalline, the subunits of which consist of one silicon atom and four oxygen atoms. Moreover, synthetic zeolites are widely used in many industries because of uniform composition, exact structure, and high purity. Zeolite can be used as environmental treatment materials such as ion exchange, adsorbent and catalyst, etc. Kosombun et al. 2018. The promising waste can be used as silica source is silica gel waste, which has a high composition of silica or silicon dioxide at 99.71%, see and Lu 2017. In the chemical laboratory, silica gel is used as desiccant and can be regenerated by removing moisture in an oven until its color turns to be dark blue as it is.
The aim of this idea research is to synthesize zeolite using silica gel waste as silica source and also modified synthesized zeolite with ferro for enhancing absorption capacity, which were tested with carbon dioxide gases. Extensive studies have been made on zeolite in terms of the structure as it relates to the properties and synthesis. According to Gogase and Paul, emphasized the importance of synthesizing zeolite in the form that suits to the industrial application.
Mostly, sodium aluminosilicate gel is employed to synthesize zeolite by several techniques ranging from the complex to very simple techniques. Example, hydrothermal treatment, according Holmes et al. 2011.
Aluminosilicate zeolites are usually synthesized under hydrothermal conditions owing to some advantages, which includes high reactivity of reactants, low energy consumption, low air pollution, easy to control the solution, formation of metastable phases, and unique condensed phases. Gentis and Lercher 2001.
Numerous studies have been conducted in searching of affordable raw materials that is suitable for synthesis of zeolite. Various ecological materials, agro-waste, and manufacturing wastes have been studied and used as a starting material in synthesizing zeolite, such as rice husk ash, coal fly ash, oil shale ash, bagasse fly ash, high silicon fly ash, paper sludge, waste sandstone cake, waste porcelain, and colonite. According to Candy and Cox, synthesis of zeolite through the hydrothermal route is a multi-phase reaction crystallization process, usually encompassing at least one liquid phase and both amorphous and crystalline solid phase. The process of synthesizing zeolite is very complex because the system is affected by a large number of modifiable factors, which may include impurities originating from the starting materials, the composition of the slurry gel, pH, water contents, reaction temperature, and time of calcination and crystallization, formation of intermediate metastable phase, silica and aluminum ratio, alkalinity, organic template, nucleation, and growth of more stable phases and aging conditions, among others.
Methodology Depth Research Widayat et al. 2019. Geothermal waste in the form of liquid heated until it becomes chunks. After that was washed, reduced in size, and sieved into 40 meshes. The dried geothermal solid waste was analyzed by X-ray diffraction to determine the chemical and its mineralogical. The zeolite was prepared by using chemical treatment and followed by hydrothermal treatment. The geothermal solid waste powder was mixed with NaOH solution 3M and AlOH3, then heated, followed by stirring at 150 degrees Celsius for 2 hours until a homogeneous was obtained. The solution was put into an autoclave reactor and heated at 150 degrees Celsius for 5 hours. The product was then washed by using demineralized water, and the research from Kausambun et al. 2018 for Fe zeolite was stirred in an iron chloride FeCl3 solution for 30 minutes, and then sodium hydroxide was added in the mixing solution, which was continuously stirred for 30 minutes. The white solid was separated and dried overnight at 100 degrees Celsius, then burned at 550 degrees Celsius for 4 hours. Finally, the white solid of zeolite was turned to brown solids of zeolite after add iron. The synthesized zeolites were finally stored in a closed container for further use. After that, the catalysts were analyzed in terms of crystallinity, specific surface area, and morphology. The crystallinity was determined by using X-ray diffraction, or XRD. The morphology was conducted with scanning electron microscope, or SEM, and specific surface area conducted by using Brunner Emmentaler, or BET. According to research Zhao et al. 2019, to test the adsorption strength, a number of adsorbent was put inside the stainless steel reaction tube. The adsorbent was first treated at 100 degrees Celsius with the 60 milliliters min N2 for 1 hour to remove pre-adsorbed CO2 and other residual solvents.
The result for this idea is a geothermal liquid waste has a potential as source of silica for the synthesis of zeolite, and using the hydrothermal method is carried out because this method is easy to apply and has the best result. For example, research conducted by Widayat et al. 2019 produced silica of 75.08% from the total weight zeolite, and added sodium hydroxide used 3 molarity because according this research has surface area maximum from a number of variables.
The conclusion from our idea is liquid waste from geothermal has been effectively converted into zeolite by hydrothermal process. The addition of ferrum is very useful to improve the adsorption performance of zeolite in the adsorption performance test on carbon dioxide cases. Suggestions that can be given are the utilization of unused waste can be done to overcome other things that have a negative impact on the environment. Starting from small things, big things can be formed. Hopefully, this idea can be realized in the future.